Hey, it's Software Student here, and today I'm gonna do a quick walkthrough of all the basic concepts of Java, or at least a relatively quick. I would expect you to have Java running on your computer and install IntelliJ, which is my preferred IDE when working with Java, and I would say it's definitely the best one on the market. So I just have an empty IntelliJ Java project opened, where I have a source folder, where I would create a new Java class. I'm just going to call it main. And at this point, we're not going to talk too much about classes, but just note we're inside our public main class. And firstly, we're going to create a hello world program, which is the first program everyone should create whenever they start a new programming language. So let's just very quickly demonstrate. So inside Java, we would need a public static void main. So I'll just do psvm tab to get a public static void main method, which allow us to run whatever is inside this method when we click run right here. So right now, run it, nothing happens because it's of course empty, but notice we're getting a process finish without exit code 0, which means we finish without any errors, which is pretty good already. So let's say we just want to print something to the console. We would just do system out print line. So I can do SOUT, which is a shortcut I will be using quite a bit in this tutorial. But just very simply, system.out.print line, and inside here, I can put some text using quotation marks, which would allow me to create something called a string, which is kind of a line of text. So I will just very simply do hello world and an exclamation mark, which is also quite important, which I will then run. And as you can see right here, we're getting hello world printed to the console. So the next concepts we're going to be talking about are variables and data types. So in Java, whenever we create variables, we will need to define what kind of type it is. So for example, if you want to create just a number, let's say just a number 5, we can't just do a. We can't just say a equals 5 and a semicolon. We're using semicolon all the times in Java because, I don't know, we love them, I guess. But we need to define what is this number 5, variable a. Let's say it is an integer, where an integer is just a number that is without any decimals. Let's say we wanted 5.2, for example, we would need a double. And semicolon. And there are quite a few of these primitive data types defining, rather than we want like a small number or bigger number, depending on how much capacity you want to be kept inside our memory. But we're not going to be talking too much about this. Just note we're using integers for numbers, double for decimal numbers. We have a char type for characters, like just a single letter. And we do this single quotation marks. Let's say a, and then we have booleans, which we would like to add as well. And they are true or false. So that's the basics of some variables with some types, primitive data type in this case. So continuing on with some Boolean operators. And we're definitely going to introduce some if statements as well in this case. So right now we have some variables. We are then able, which is more or less what everything is built upon, check if something is true, so whatever's inside these parentheses is true, execute this code block. So let's take our system that are the print line of hello world and now say if d print hello world. But right now d is set to false, so when we run the program, nothing would be printed because it's simply checking if d equals true, print, checking d equals false, don't print. So let's say if we change d to true, we would now get hello world. Then we have our Boolean operators, which allow us to, let's say if we had both a Boolean d, which is true, but also a Boolean E, which is false. We'd like to say if D is true and, which are done by using these AND operators, and E is true, print. So now if check is if D is true, it is, but E is false, so don't print, because we need both of them to be true when we're using AND. We then have our OR, which means if just one of them, which is done by just using a line. So now we would have if D or E is true, print, and we're printing because D is true. But if we enter D to false as well, we would not get anything. There we go. Then we have our, we're using these at the moment. Then we have our XOR, which at first can be a bit confusing. But XOR just simply means we need one to be true and one to be false. Exactly. So if we change this one back to true and run again, we get hello world again because it checks if one is true and one is false specifically, then print. So right now we're just setting them specifically, which kind of doesn't make too much sense, but what we can do is we can also check using mathematical operators. So let's say if A, and because we use the equal sign to declare variables, if we want to check if numbers are the same, we would need to say if A equals B, print. So we're checking if A is the same as B, print hello world. In this case, it isn't. We can also do if A is larger than B, print. Again, it isn't. If A is smaller than B, print. And now we should get hello world. And similarly, like basic math, we can do smaller than or equal to or larger than or equal to. We then also have our not operator, which means if they are not the same. So instead of doing equals, we can do exclamation mark equals, which means if A is not the same as B, print. So if they're different more or less. And we print as well. So that's more or less our basic Boolean operators. Then have a bit of a closer look on our if statements. So as mentioned, do a simple if true, if this entire block is true, print. Let's just add, so again, E. Now E would be false, so we don't do this one. We can then add else if, so a second block, which would first, it would check the first block. If the first block is false, and only if it's false, go to the next block. And let's add D. And we would simply print, well, here we go. So now it would first check E equals false, else if D equals true, print this area. And we can then also add an else block, which means if everything else fails, just do this. And we would just go, everything else failed. Let's say we first check if E equals true, which would be false, and we then check if A is larger than B, which would also be false. We would then print everything else failed. Well, kinda sad, but in this case it worked out as well. We then have a different way of doing this, which is what is called a switch. So instead of doing, let's say we had an example where we need to check like a lot of numbers, we can very simply do a switch. So let's actually set up a few numbers. So I'm gonna be creating int b equals 3, int c equals 5. We're then gonna create a switch, which is gonna take some input. Let's just take it A. We're then gonna create a code block where we would do case. So if A equals 5, for example, we would do system out print a is 5, and we would then break. We're adding a break as well, and I'm gonna be explaining shortly what that means. And we're gonna go a, maybe not a, that doesn't make sense. Let's go to input. Actually, just copy paste this one. This would be if the input is 3. And again, we do a break. And I'm gonna add a third case. So if the input is 7, and like with the if else statement, we are getting at a default, which is very simple. If everything else fails, we're just gonna print default in this case. And what the break does is normally the switch would check all the cases, but if we hit a break, we would skip out of the ongoing switch. So now, when we run this program, we get the input is 5, because what the switch does is it's more than if else statements. It would first go input is A, it would then check if A equals 5, print this line, and break, so jump out and stop the switch. If we didn't have the break statement, it would check as well if A equals 3, if A equals 7, and so on. But in this case, we don't want it to check all the cases. We might want to, but for now, we don't want to check it. And we can check it, let's change it to B. And the input is 3. And C, the input should vary. Probably be 7. And let's just say if we added a number ourselves, let's say 10, for example. And we should now get false. So that is pretty much our switch. So let's have a look at branching. It's kind of adding on what we've been learning for the last minutes, where we would be using what is called loops, more or less. Where we could have a while loop. So very simply, while something is true, execute code block. So let's say while, let's for example set A to 0 and say while A is less than 5, system out to print number A and add 1 to the number A. So A++ is something we also I would like to talk about. So instead of doing A equals A plus 1, which means every time we just take the previous number of A and add 1, so this would work as well. So if you paid better attention than me, you would have noticed, like of course nothing is being printed, because I'm very simply checking if A is larger than 5, and it's never larger than 5, because 0 is not larger than 5, I should have while A is smaller than 5. So now, we should first get A equals 0, print 0, then add 1, then we run again, plus 1, so A is 1, plus 1, A is 2, 1, A is 2, 3, and so on. And as mentioned, we can shorten our A equals A plus 1 to just being A++, because very often we would need to add just 1 to a specific variable. So we like doing A++ because it's a bit cleaner, and if we run the program, you can see it's working the exact same. So we also have a do while, which kind of works the same way, where we would say do something while something. So do, let's print A, and then add 1 to A, while A is less than 5. So very much in the same way, but the output is going to be a bit different you noticed, where we previously check before, so check and then print, now we print and then check. But in this case, we get the same output. We then have the third one, so the while loop is used quite a lot. The do while is not used, it's also used, but it's not the most used. And then we have what's probably used the most, which is a for loop, which can be a for I to be more precise, which can be a bit confusing at first, but it's actually doing the exact same, but in one line as we've been doing so far. So what it is doing is we're having an integer value set to 0. We're then saying while this number is smaller than 5, execute this code block, and then add 1. So where we previously had a outside a variable outside our loop, it's now integrated into the loop as part of the loop. And in this case, we just print I. And you can see we get the exact same output again, because we first check I is smaller than 5, print I 0, add 1, I is smaller than 5, I equals 1, print 1, add 1, 2 is smaller than 5, print 2, add 1, 3 is smaller than 5, print 3, add 1, 4 is smaller than 5, print 4, add 1, 5 is not smaller than 5, stop. And what we learned previously, we could also do like a break, which kind of doesn't make any sense at all, because now we would run one time and then break, so stop. But just to showcase the break again. So break just simply breaks out of the loop of if statement or for loop or any kind of loop. So let's see where we're at now. So now we've been through our hello world, talked about a few primitive data types, some variables, some Boolean operators, which allow us to do like if-else statements, simple if loops, have a switch, we have some simple loops. We're then going to talk about how we're able to contain and keep data. So let's have an array first. So an array in Java, just a very simple data structure where we're allowed to keep some data or multiple variables or multiple values inside one variable. I don't know if that makes sense at all, but let's demonstrate. So we have an int array using these square brackets now to determine its array, where previously we just do a normal integer. So it's an integer array, so an array containing integers. And we are gonna call it numbers, which is gonna equals to a new int array. And we need to define the specific size of the array. So how many numbers can this array contain? So let's just say, let's say 5. So now the array would look like this. So another thing, when doing 2 backslashes, we have a comment. So here I can write whatever I want and it's not going to be executed. But let's have a look at how it works, how it looks. So an empty, let's see if I got it right. 1, 2, 3, 4, 5. Yes, an empty array in Java, because it's an integer array, would all contain the numbers 0. So this is how it is looking right now. And how we actually get the numbers out of our array is using a for loop, like we just talked about. But what we can do, which is quite smart actually, is saying while our I value is smaller than our numbers array dot length. So it more or less means for each number inside this array, let's get our print to the console and just very simply print our numbers array on I specified index. So our array works with an index where our first number in our array have index 0. Let's actually demonstrate. So this is index 0. This is index 1. This is index 2. This is index 3, and this is index 4. Which allow us, because like if you saw last time when we were doing it this way, we were printing the numbers 0, 1, 2, 3, 4. And if we, before actually doing this, so this is a larger comment where I also comment multiple lines. Let's first actually just print the size of our array, because even then we're telling it the size is 5. Notice that our array have the last index of 4, and in Java we are able to use methods on stuff by simply doing a dot operator. So we can do numbers.length, and we're then able to get the number 5. And if you remember just a few minutes ago when we printed, we did while I is smaller than 5. And we got the numbers 0, 1, 2, 3, 4. So now we are able to get all the numbers from our array by iterating through our array and using our for loop and printing all the numbers in our array. And we're using print ln, which means print a new line. So we get 0, 0, 0, 0, 0, as mentioned. But let's actually add some numbers to our array using the same method, where we would simply say numbers array on spot I is going to be equal to the value of I. Actually, let's not print the numbers. Let's just very simply add them. And of course, you might notice we actually don't get any output, because we're just adding the numbers and nothing. So let's create a new for loop down here, where we actually use a different for loop for each loop, which actually often confuses quite a lot of people, but it's actually not that hard. So what we simply need to do is to define first what kind of data type is we're going to be using in this for each loop. So it's going to be an integer, because our numbers array contains integers. We're then going to give it a variable name. So when we walk through the numbers in our array, then for each of them we're going to give them a variable declaration name. And which array are we going to go through? We're going to go through numbers. So what this is going to do, it's going to go through all the numbers inside our numbers array, which are integers. And it's then going to set this a value to the value of the specific index. So first it would say a is set to the index 0. And what is on the 0? What that value is going to be set to a, which in this case is going to be 1, because we're going to adding all of the specific numbers to our array. Let's just print it to demonstrate. It's just very simply printing a. So now what we're doing, we're first adding to number 0. That's not very good. There we go. On the index 0, add 0. On index 1, add 1. Index 2, add 2. Index 3, add 3. Index 4, add 4. Then we are going through all the elements in our array and setting the variable a to index 0, which have the value 0, print 0, set it to the next value, which in this case index 1, 1, print run, and so on. So that's pretty much our for loop and our for each loop. As mentioned, our for each loop is probably a bit confusing at first, but when you get the hang of it, it's actually very, very useful. That we're able to, as the name suggests, to go through each of the elements in an array. Then we have a few more things to go through. I'm actually going to skip the methods for now and talk about lists first. So where we had our array, where what's very important and very specific about an array, let's create it again, is our int array, is that we need to define the size of the array when creating them. They have a specific size and we can't go above this size. We can't add a number to index 7 because they only have index 0, 1, 2, 3, and 4. But then we have a list, and more specific, an array list. And then in a different way, we need to define what they contain, in this case, the integer as well, or a name. Let's go numbers 1 equals new array list. And what you might see, it doesn't like an integer because it actually cannot take any primitive data types. It only takes objects, which we haven't discussed at all, but just notice that we need to go into instead. Ooh, if I can get it right. There we go. So we're using integer, which is the same as an int, but a different, yeah. Just note that when using integer, that's not really the important part for now. For now, just note that array list works in the same way as an array, but instead of having to define a specific size, it's gonna fit to the numbers. And where we would previously, when adding numbers to array, we need to define, so numbers index 0, add the number 1 to 3, for example. With a numbers array list, we can just go numbers 1 dot add the number 1 to 3. And we can then continue adding numbers. So let's go 1 to 3, 2, 3, 4, I don't know, 33, 3. And then in the same way as last time, we are able to just go for each integer a in numbers 1, print a, and we would now just very simply get 1, 2, 3, 2, 3, 4, and 3, 3, 3. So that's our array list. Quite easy. It can get way more complicated, but for now, just notice different way of containing numbers than our array list. Let's go to the next subject. But actually first, notice up top here, when we started using an array, we imported java.util_ArrayList, which means we're importing some usability from a package or library, which means it's not a part of the basic Java program, but it's part of the util package. But just notice for now that IntelliJ is doing all this automatically because we're using this pretty good IDE. So actually, I just think we're gonna wait with methods until next video, where we're gonna be talking about OOP, object-oriented programming, which is like the core or the main reason we actually use Java. But let's just talk a bit about lists and maps. Oh, we just talked about lists, actually. So let's just talk about maps. So a map in Java, a hash map. And again, notice we are importing util, that hash map in this case. Takes in 2 inputs, or we need to define where with our array list. We just need to define, for example, it was taking an integer. With our hash map, we need to give it a key and a value. So first, a key value, let's call it integer. If I could do it correctly, integer, but internal error, integer. I'm gonna do a string. And let's just simply do some, I don't know, read names. Example, which equals a new hash map. So our hash map will allow us to do street names dot put, where, as you can see, we'd have a key and a value, where our key is the number that allows us to get our value back. So let's say our key 0 is this street. And as you can see, we have autocorrect inside IntelliJ as well, which is also quite useful. We can then have a different set of names where, let's say, the key 24 is some other street, and so on. Well, we have some kind of key value, which allow us to get some kind of value. So they're matched together, so whenever, let's just print our street names dot get. We then can input the key, example 0, and in this case, when we print, you might see the output is going to be the street. Or when we input the key 24, the output would be some other street. Yeah, so this is pretty much the basic subject I want to talk about in this relatively quick. I know it's not too quick now, it's almost 30 minutes, but these basic concepts of Java. And I know it might be a bit confusing, these lists and maps for now, but just hang on, you definitely get the hang on it. And if you continue with my next video, where we're going to talk about the next part of this OOP, methods and classes and objects and so on, it definitely going to make everything a bit clearer. But if you enjoyed this, as mentioned again, relatively quick walkthrough of the basic concept of Java, please leave a like and subscribe, and I wish you all a wonderful day.